You know, if you've ever had to manage cloud infrastructure, you know the feeling. It starts out simple, right? But then it just spirals into this incredibly complex web of services. The old way of doing things, manually clicking through menus, it's not just slow, it's a recipe for disaster. So today, we're going to dive into a much, much better way to build, turning your entire infrastructure into code. And really, this is the big question. It's the thing that keeps developers and ops teams up at night. You add a server here, some storage there, a network, and before you know it, you're wrestling with this tangled beast. Trying to update it feels risky, and spinning up a new, identical environment? Forget about it. It's almost impossible. So, how do we get out of this mess? How do we escape the chaos? Well, the first big idea to fix this was infrastructure as code, but, well, that created its own set of problems. The biggest one, the monolithic file. Just picture it, a single 1,000-line blueprint for your entire system. If you want to change one tiny little part, you're holding your breath, hoping you don't break everything else. And if you want to reuse that networking setup for a new project, you're stuck copying and pasting, just praying you didn't miss something. Okay, take a look at this. This is a perfect example. This one Bicep file defines an entire Windows VM setup. We're talking the machine, the IP address, the network, the storage, all of it. But the problem is, it's all fused together in one big lump. If all you need is that storage configuration for some other project, you're back to copy-pasting code. And that's where the mistakes and the inconsistencies start to creep in. And this, my friends, is where the hero of our story enters the scene, Azure Bicep. Now, this isn't just another coding language. Think of it as a specialized tool built for one purpose and one purpose only, to tame the complexity of the Azure cloud.
Let's break that down because it sounds a little techy. Domain-specific just means it does one job, and it does it perfectly, describing your stuff in Azure. And declarative syntax, well, that's the magic. It means you just state what you want at the end. Hey, I need a storage account that looks like this, and Bicep figures out all the complicated steps to make it happen. The result? Way cleaner code and way fewer headaches.
So what is Bicep's superpower? What makes it so different? It all comes down to a really simple but incredibly powerful idea: modularity. Instead of building one giant, monolithic thing, we're going to build with smaller, interchangeable pieces. Honestly, this is the absolute best way to think about it. Every module is like a specific Lego brick. You've got a brick for storage, a brick for networking, a brick for a database. Each one is totally self-contained and standardized, and you can just snap them together in any combination you want to build exactly the structure you need, and you can do it quickly and reliably every single time. All right, enough talk. Let's actually see this in action. We're going to take that big monolithic file we saw earlier, and we're going to break it down into a clean, beautiful, modular solution. And you know what? The process is so straightforward. It's really just two simple steps. First, we're going to pull out one piece of our infrastructure, let's say the storage account, and give it its own dedicated file. And second, we're going to replace that big chunk of code in our main file with just a single line that points to our new module. That's it. So first things first, we dive into our main file and we find the block of code that defines that storage account. This is a perfect candidate for a module, right? Because pretty much every application out there needs a storage account. It's a common, self-contained piece that we're going to use over and over again. Next, we literally just create a new file. We'll call it storage.bicep, and we move that storage account code right into it. This file now has one single focused job: define a storage account. And just like that, we've created our very first Lego brick. Now for the really satisfying part, step 2. We go back into our main file, we delete that original block of storage code, and in its place, we add one simple, clean module reference. This little line just tells Bicep, hey, for the storage part of this puzzle, go look at the blueprint in the storage.bicep file. It's so clean, so simple, and anybody can understand what's happening. And look at the difference. I mean, it is just night and day, right? On the left, you've got this cluttered all-in-one file that's a nightmare to navigate. And on the right, you have a clean, organized main template that clearly delegates tasks, like creating storage to its own dedicated reusable module. Anyone can look at this now and immediately grasp the architecture. Okay, so having this clean, well-structured code is fantastic. But the real magic, the real power, comes when we connect it to an automated deployment process. This is where we stop just writing code and start building a true DevOps workflow. Now, this might look a little intimidating, but it's actually pretty straightforward. This is a YAML pipeline for Azure DevOps. Think of it as the instruction manual for our robot builder. It points to our main Bicep file, it tells it which Azure subscription to use, and it lays out the exact steps to turn our code into real, running infrastructure in the cloud. And here it is, the payoff. We click run, and that's it. The pipeline just takes over. It grabs our modular Bicep files, it figures everything out, and in just a couple of minutes, look at that, 2 minutes and 55 seconds, our entire environment is built from scratch, perfectly, every single time. No manual clicks, no chance for human error, just fast, reliable deployment. So, what does this all mean? What's the bigger picture here? Well, this shift towards modular, automated infrastructure isn't just about writing tidier code. It is fundamentally changing how we build and deploy technology. So let's just quickly recap the key takeaways. Bicep modules make our infrastructure code readable, so anyone on the team can understand what's going on. Because it's modular, it's reusable. We're not reinventing the wheel anymore. The automation makes our deployments reliable, taking human error out of the equation. And all of this put together means our systems are scalable. We can now manage incredible complexity with total confidence. And that leaves us with a really fascinating question to ponder. When building the very foundations of our digital world becomes this automated, this efficient, it frees up all of that human brainpower to focus on bigger, more interesting challenges. So, as we perfect the art of building the what new complex problems will we turn our attention to next? Thanks so much for joining me for this explainer.
So here I have already connected to Azure DevOps. Select this project. So the very first thing, we need to create a service connection to access Azure resources. So here I am going to create a service connection now. So for that, here on the left side you see that product settings, select that one. Then service connections under pipeline, select that option. Select create service connections. Select the Azure Resource Manager. Select next. Then pass all the values for identity type, credential, scope level, subscription, select the resource group, and give a service connection name, and make sure that grant access permissions to all pipeline is disabled or unchecked. Then select save button. So now we have completed the necessary prerequisite steps to continue with this lab. So now we will go through deployment using Azure Biceps template. So for that, very first thing what we need to do, we need to import the repository. So for that, select on the left side repositories. Then under files, see that import options. Under import repository, select that button. Now here pass the source GitHub repository to clone that one. And then select import. When import is successful, you will see folds and files like structure folders and files which actually contains Azure DevOps YAML pipelines and other necessary websites related information for the lab scenarios. So now let's make that main branch as a default branch. For that, you see that branches options under repos. Select that one. Go down, main ellipsis button, and set as default branch. Now we'll go through Azure Biceps template. So for that, here you see repositories, click files, and here is the different folder structure. Select that infra folder and look for simple Windows VM biceps file. And you can see the template structure. You will see here like params related to parameters. Also, you will see the variables and resources. The resources you can see here like network security group, public IP, virtual network, NIC. So now let's create a biceps module for storage structures. So for that, click on edit button. So from here, we're going to delete the storage resource. So this section you see that is storage account. So we are going to delete that part. And then next public IP here. Let me modify all the options which is defined here. So here you see that the public IP allocation method parameter we have to set up 920, that which is dynamic. We're going to set that into static. And then line 27, here you see that the public IPSQ string is basic. We're going to set that to standard. After that, line 58, where VM size string is standard P1MS, we're going to change to standard D2S P5. When that is done, click on commit. Click commit. Now next go back to here that infra folder and select the ellipsis button, and here select that new and file, and here you put that new file name infra storage biceps and then select create. Now here copy the code from the document and then click on commit to changes. Select commit. Now here is that simple Windows VM biceps. So back to there and select edit. And going to add code after all the variables. Now modify the reference to the storage account below URI in the virtual machine resources to use the output of the module. So find the virtual machine resources. Here diagnostic profile, boot diagnostic, enable is true. We're going to change that this part is storage URI. Now select commit, select commit. Now deploy the template to Azure using Azure YAML pipelines. So for that, navigate back to the pipeline. And this pipeline, and here create pipeline. Select that Azure repos git. Then select the repository. We are selecting eShop on web, the 597444032. Configure your pipeline. We are going with existing Azure pipeline YAML file. Then select branch and select the file. Click continue. So in the variable sections, the resource group, and location is, in our case, that is West Central US. Then select save and run. Click save and run. This pipeline needs permissions, so select view, give the permission, again permit. So build is in progress, select that one. and you can see deploy or build is in progress. So let me back when that completes. The deploy has been completed. Now let's go to the portal. We go to the resource group. And we can see all services has been created. So here we have used our custom biceps template and deployed